In the previous lecture, I had given you the definition of a tangent, and in this lecture, I would like to cover a few facts about a tangent. So, according to the definition, a tangent is a line that touches the circle in a single point. So, we have a tangent PQ over here because this line PQ is touching the circle in a single point B. And you can even say that it intersects the circle in a single point. Basically, this is a point that I wanted to clear out because in your textbook at different places they have said it intersects the circle in a point or it touches the circle in point, but it really means the same thing. You can say that it touches or it intersects the circle in a single point, it means the same thing. Now, we can say that point B is actually the point of contact between the tangent and the circle. Similarly, we know that line MN over here, since it is touching the circle in a single point A, we can say that A is the point of contact between the tangent and the circle. Alright? That takes us to the next point. Circle can have infinite tangent. Now, what does this mean? For that, let's first make a circle. I'm sorry, it didn't quite work well. Alright, so we have a circle. Let's say it has a center O. And in order to construct a circle, what do? We place the pointer of our compass over here. We measure a certain radius. Right? We measure a certain radius. Let's say 5 centimeter. And then we drag our compass around. Essentially, what are we doing? We are creating a line which is joining several points that are equidistant from the center, from this point over here where we place the pointer of a compass, right? So basically this set of points on this line, which we call the circle, are equidistant from the center. And how many such points can we say are there on the circle? Infinite. A circle is actually a set of infinite points which are simply equidistant from the center. So since a circle is actually made up of infinite points, can we draw tangents through these points? Yes. So at every single point we can have a tangent. Let's say if we want to have a tangent over here, is that possible? Yes. We can basically have a tangent at this point also. We can have a tangent at this point also. And similarly, we can have a tangent at every single point on the circle. So we can say that a circle can have infinite points. That takes us to the next point. Now, what are parallel tangents and how many parallel tangents can exist? Now, we know that we have already discussed that a circle can have infinite tangents. So when we look at parallel tangents, we really are looking at just a pair of tangents at any given point. So here we have seen line PQ and it is touching the circle at point B. What if I draw the diameter for the circle from this point B? And so how is the diameter formed? A diameter is basically a line such that it joins the points which lie on the opposite sides of the center. So A and B are those points, right? So they are exactly opposite to each other. And if we draw a line such that it passes through this point A, which we have already done, therefore line MN and line PQ, can we say that they lie exactly on the opposite sides of the center? Yes, we can say that. And thus they are parallel to each other, right? So parallel tangents are possible, and basically every tangent will have one single tangent parallel to it, right? So PQ is parallel to MN, or if MN is our given tangent, we can say that PQ is its parallel tangent. At any point, or at any given point, a tangent will have another parallel tangent, right? So two parallel tangents at a time is possible. That takes us to the last point, a special case of secant. They say that the tangent is a special case of a secant. And why is that so? We know that a secant is basically a line that is going to divide the circle into parts. So for the sake of this video, I have already made a diagram over here, and let's say this is line L, and this line L is intersecting the circle in 2 points X and Y, right? So X and Y are basically the 2 points, right? And so what if I start dragging this secant down? What will start happening then? Let's say I've dragged it by this much distance. Okay, I've dragged it down by this much distance. Now you'll notice that the intersecting points X and Y are actually getting closer to each other. They are getting closer to each other, right? What if I pull it further down? They have again come closer to each other. Now I'm going to drag it to a point where X and Y will actually coincide with each other, right? And the secant which is passing through points X and Y will now actually touch the circle, right? And according to our definition, any line that touches the circle at a single point is nothing but a tangent. Therefore, a tangent is nothing but a special case of a secant, where the two intersecting points of a secant, right? The two intersecting points of a secant are actually coinciding with each other. And then in such a situation, the secant becomes nothing but a tangent. Therefore, a tangent is said to be a special case of secant.